To become an Oracle Certified Professional, developers must pass a single 90-minute test, Exam 100829. Oracle consolidated the certification path. This single exam demands equal fluency in decades-old legacy edge cases and the newest SE17 features. Writing successful production code every day does not translate to passing this exam. The daily skills required to build applications do not map to the skills required to survive this test. The exam does not measure what you can build. It measures whether you can perfectly emulate the strict logic of the Java compiler under extreme time constraints. Look at this Java 17 stream pipeline. A working developer skimming this code will recognize a standard operation, generating strings, filtering out the empty ones, and collecting the results into a partitioned map. The compiler sees a completely different reality. It recognizes a flaw hidden in the execution order. Uncovering that flaw requires a systematic method. We use a three-part decoding checklist. First, does it compile? Second, track the state. Third, isolate the noise. Surviving the OCP exam requires abandoning your gut instinct and rigidly applying this mechanical checklist to every single code snippet. Protocol 1 of our decoding checklist: before you attempt to trace a single logical loop, you must first verify the syntax. This is a modern Java 17 switch expression being used in a variable assignment operation. Switch expressions used in assignments must yield a value in every conceivable branch. On line 44, the default case has an if statement yielding unknown, but there is no yield if that condition evaluates to false. A second structural failure exists on line 47. The entire case score 2, 0 block lacks a yield statement entirely. The code does not compile. By hunting for these structural compilation blockers first, you confidently skip time-consuming logical evaluations. Once a snippet compiles, the exam attacks your ability to track variable state changes over time. Take this dense block of math, ternary operators, and consecutive reassignments. We track the state visually. Moon starts at 9, and star starts at 8. Strict operator precedence forces the multiplication to occur before addition. Star equals exactly 8. In the next line, the ternary operator evaluates star greater than 10 as false, targeting the integer 3. That integer 3 is assigned to sun, which is declared as a float. The compiler implicitly promotes that value to 3.0f. This implicit promotion cascades into the calculation for Jupiter. We calculate 3.0f plus 9 minus 1.0f, yielding 11.0f. Assigning that to a double variable forces another implicit promotion, landing at 11.0. Relying on mental math for these shifts leads to errors. Rigorous visual diagramming is the only defense against implicit type promotion. Next is the psychological trap: embedding unrecognized, out-of-scope APIs into questions to induce panic and waste time. Here we see logger.anonymous logger. You must treat unknown classes as perfectly functional, irrelevant black boxes. Look exclusively at the variable modifiers. The actual error is a foundational Java rule violation. The second line attempts to assign a new value to a variable marked final. To find the core constraint violation, you have to aggressively filter out the structural noise. The exam treats macro-level infrastructure with the exact same rigor as line-level logic. This is highly visible in Java 17's module system. Look at this module-info.java file. A standard question will ask you where this file should be physically placed in a project directory. File placement in the root directory is a real rule, but it is offered here as a secondary distraction. A module declaration is strictly forbidden from using the public access modifier. Directory location is irrelevant because the core definition is inherently invalid. We have our decoding checklist: compile check, state track, black box, and architecture. Now apply this checklist to the complex stream snippet from the beginning of our analysis. Step 1. Does it compile? Yes, this stream is syntactically flawless. Step 2. Track the state. Stream.generate endlessly produces empty strings into a buffer. The filter requires a non-empty string. Because the source generates only empty strings, one will never arrive. The pipeline perpetually starves. A syntactically perfect stream fatally locks up at runtime due to logical starvation. The OCP SE17 developer exam is a study in systematic evaluation. You cannot rely on IDE autocomplete memory or your daily production intuition when facing these deliberate compiler traps. Adopt the micro perspective of the compiler. Aggressively hunt for compilation blockers, visually map your variable states, and ignore architectural noise. By reverse engineering the compiler's own rigid constraints, the certification reveals itself as a sequence of predictable, verifiable logical steps.